Performing a cable ID with the Easy Cable ID unit.
Hello, we're going to be introducing the cable ID unit over here. The cable ID unit consists of, the Easy Cable ID consists of the receiver, which we have over here. And the receiver is a menu operated receiver. It has several buttons. It also has a backlight display you can see over here. So if you're working in the dark, you can have a look at the display if you're inside a manhole, for example. Likewise, it has a connector over here where you can connect different types of transducers. We have the one over here, which is the Rogalski coil. That is used for single-phase cables. And then we also have another one, thank you, which is the puck, as we call it, pickup coil, which you can use around single-core cables as well as a secondary test, but primarily used for three-conductor cables. So that's the receiver, and they simply plug in over here. This has got 4 AA batteries in it. You just unscrew that, unclip it, and you can replace the batteries. The unit will automatically turn off after some time. You can adjust that power off setting, or you can leave it on permanently. To turn it off, you just hit the power button like that, and the unit will turn off. So that's the transmitter. The receiver. We also do have a lanyard connected to it, and so you can put that around your neck. And it's got a safeguard on it. If you catch anything, it will hopefully pull off. So it's got a way to break the connection. So that is the receiver. In condition, we have the transmitter. This is the transmitter over here. This goes at the sending end of the cable. Typically, we'll go either at the starting point at the cable, at the breaker, or at the riser. You can get various lengths of cables. There are 2 cables that are connected to it. This is the one output port over here, and this is the other one. This is L1, this is L2. And this has also got a battery in it. The battery lasts for several hours. It's easily replaced if you ever want to replace it, but it is rechargeable. Rechargeable through this port over here. You can also operate the unit with the AC power in here. We also have a DC auto jack port that you can plug into your car's cigarette lighter outlet for that port over there. To turn it on again, you simply turn it on. It's got 2 modes of operation, either what we call 3-phase operation, or we have single-phase operation. You just click this button over here, and you can change it from 3-phase to single-phase. So single-phase is right now. Click it again, and we go back to the 3-phase mode. These red lights are red because we don't have a complete loop. What we want when we have a complete loop is a green light. So for example, if I connect this over here, go back over here to single-phase mode, and you'll see if we short circuit the output, it goes to green. If we open circuit it, in other words, we have a bad connection, it'll go to red. There we go. All right, so that is the transmitter. Battery operated or AC operated, and that injects the signal down the cable, or the pulse is down the cable. In addition to that, we also have, we could either hook up directly onto the cable. If we hook up directly onto the cable, we use this lead over here that we plug into the transmitter. And then these leads over here will connect, that will go onto C phase, the black cable, and the red cable will go onto A phase or B phase. This particular cable is L1. If you look over here, so let me turn that around, L1. So that will connect onto C phase here and A phase over here. Likewise, if we're doing a 3-phase cable, we will connect, you can see over here, this will say phase 2, look there. The red cable will go onto B phase, and again, the black cable will go onto C phase. So you're going to have 2 cables on C phase, and you're going to have 1 cable on B phase, this one over here, and then the other cable will go to A phase. If you wanted to show the drawing, we can show the the main drawing of what we're describing here on the sending end. You've got two black cables going to C phase, and you've got A phase having the one red cable from L1, and your B phase being the other red cable from L2. And that is your connection on the sending end from the transmitter. Okay, apart from hooking up directly like we've just shown over there, we also have the ability, if you go down to look at the induced method, where we can induce onto a live cable. How we do that, these live CT clamps have these ports over here, which are banana female ports. And what you do, you take that same cable that you had before, and you connect red to red and black to black. And now you connect that through the cable, and you then have the ability to induce the signal into the cable. This is called the indirect mode, because we are inducing into the cable, can be used on live cable. This method does have limitations. We'll talk about them later. Preferably, you always want to use the direct method on a de-energized cable. Yeah, just having a look at indirect method, you can see there the CT clamp connected around the cable in question. All right. So next we'll do the hookup. We're going to do a direct connection first. So Cody, if you can shine down on this board over here. And what we're going to be doing is connecting A phase that we're going to be hooking up onto the one side of the cable. So we'll call this guy over here L1, and this over here will be our C phase. So this is A, B, and C phase, or L1, L2, L3. And likewise, we're going to hook on the other cable to black cable to C phase, and this one being L2 over here. So this is actually wrong around. This is L1. Put that up there, and this is L2. So this says over here, this is L1, that goes up here, and this is L2, and both C phases go in here. This cable over here is just there to confuse people so that we can make sure we don't identify that one incorrectly. This is the one we want to identify. Next thing, we need some jumpers on the far end. On the far end of the cable, we're just going to jumper all three cables together, A, B, and C phase, like that. You can ground the far end of the cable as well. So if you wouldn't mind bringing up the schematic of what we've just done, that's the direct injection. So that's exactly what we've got here. The far end of the cable is grounded. The near end is connected to AB and returns on C phase. So with that, we can turn on the transmitter. Here's the transmitter over here. I'm going to turn it on. Because we're doing a three-phase ID, I want to make sure we're on three-phase. And I also want to make sure that we have the green lights on. If we didn't happen to have a ground on the far end, or sorry, the C phase connected to the A and B phase, we would not get a green light here. So that's important that we get green lights when we do that test. So everything's good to go. There we go. Now we take our receiver. Because we have individual cables that we can get around, we're going to use our Rogalski coil, which is this guy over here. We're going to turn on the unit. And we're going to do what we call uncalibrated mode first.
Uncalibrated mode is when you do not have to verify the amount of current at your source. You are only picking up the unique signal coming down L1 and L2, with the two signals returning on L3. This mode is quicker, but it does require more understanding.
Receiver, that's the first screen. What we're going to do is connect first onto our cable that we believe to be one of the right cables. We make sure that the arrow is in the right direction. Some utilities face us towards the transmitter, some face it away. In our case, we're facing it away right now. So that's what we make sure is the arrow is in the correct orientation. So you can see the arrow down below there. And at this point, we want to find out what are we on? So we just say identify. Is this a short cable or a long cable? We're obviously on a short cable here right now. And then the unit should identify for us. And hopefully it will be L1. It's now looking for the signal, and there you have L1 positive, which means it's in the right direction, and it's L1, and you can see we have around about 33 amps that are being injected into that cable right now. About 30 amps. Let me get the reflection away. There we go. Now, if we move that from the top, and let's say we go down to the second phase, making sure the arrow is in the right direction again. Let's go look at the display. And we should have hopefully L2, and the current should be about the same. You can see around about 30 amps as well. Okay, so there's L2. Then finally, we'll go around the third phase, and we should have here a big negative. And that negative, there we go, that negative should be, if we go and press this button over here, there should be both L1 and L2 present in that negative. And that's exactly what it should be, and it's completely negative, which is correct. And again, the current should really be around the 25 to 30 amps, and you can 25 to 30 amps. And if you look over there, we've got about 25 to 30 amps, which is correct. Now, let's go to the wrong cable. There we have the wrong cable. And you can see there it's showing, let me just point it down. There we go. Showing no signal. Leave it on for a bit. It's saying question mark is not the correct cable. You can't identify it. Okay. Now, there is another technique we can use. Some customers prefer to have what we call a calibration mode as well, where they can identify at the known point the exact currents flowing. And we will do that now. That now requires 2 steps. And let's go and show you how that works. First of all, what we do, we go to the known point on the cable. So this cable is pretty short, but you get the idea. We'll go to the known point, which is here. We know for a fact that this is L1 over here, because we write at the, let's call it the breaker or the riser. We know it's L1, and we say to it, please go and identify this cable. So here we go. And it should say L1 question mark. In other words, it's asking you as a user to confirm that you are in fact on your L1 phase. And you go back and you look at where your transmitter is connected. You make sure the breaker nameplate says A phase, or the riser says this is A phase. And you see L1 question mark, and you say, yes, that is correct. There we go. L1 is correct, and your little check mark is in L1 there too, saying it's captured that. Then you go to, get out of the way, your second phase, your L2, and you do the exact same thing, and it should come up and say to us L2 question mark, and that's exactly what it says, and you say yes it is. And now it will store that information inside the unit. Now you see an L2 smiley face. That means that you've met the threshold where we're at, that exact current that is looking for down the line is exactly correct. Well, obviously we haven't moved this yet, so it would be correct. Now, we would take this off, leave our known reference point on the cable, and now we would walk down the cable to the manhole or wherever that we have access to the cable. Once we get to that point, we'll put this on and say, hey, what is this? And it should come back with an L1 smiley face. And there we have it. Likewise, if we go down to the wrong cable, That symbol there says can't find signal. There's a pulse there with an arrow through it, means that is not a valid signal. That's what is showing there. Let's go to another cable. Hopefully this is L2. There we go, L2 smiley face. And then finally, on the returns on C phase, which will be perfectly correct, it'll be unique to the C phase, we should have a big negative. And that big negative means that's your returns on C phase. And there's your big negative, and we press L1. You can see there's L1 in there and an L2, both flowing in the negative direction. In other words, that's exactly what we want to identify C phase. So there you have it on a three-phase cable. Now we'll show you later on a more longer cable, not a short board like this, but the principles apply. Same principles apply. Okay, so here we have a paper lead cable. It's a 3-conductor cable. You can see the 3 conductors. We've actually just labeled them L1, L2, and L3. Because the cable's cut, we've got little nails put into the individual conductors over there. 3-conductor paper lead cable. All right, I'll put that up there. Okay, so with that, same deal. We're going to do a direct connection. Make sure we choose, this is our L1 cable. So red cable, red clamp goes on L1. Black cable, return goes on the L3. Red cable goes on L2 from L2. Black cable goes on the return C phase. So that's done. On the far end of the cable, Cody, if you can just kind of point over here, you can stay there. But all you want to do on the far end, no, just look. You just go connect a jumper on the far end of the cable. So again, same deal as before. The jumper goes from A phase to B phase to C phase. You can, if you want. Right now, all I've done is jumpered them, which is all you need technically for this to work. If you want to take those jumpers to ground on the far end, you can do that. From a safety point of view, you can do it. Don't have to do it from an identification perspective, but it is important that A, B, and C phase are jumpered together. And then if you want to take them to ground, you can. All right, same deal again. We're doing a 3-phase ID. Turn it on. We want green lights. We've got green lights coming up there, which is good, which means we have a complete loop. And now what we want to do, because we have a 3-conductor cable, we can no longer use a Rogalski coil. Now we use this puck. Again, the arrow is important. We want the arrow because we're going down, in our case, to the far end. We want the cable to go around, the puck to go around the cable with the arrow facing down. Again, for those of you who are used to facing the arrow towards the transmitter like that, we can set the receiver to accommodate that as well. So both methods of operation are optional and you can set them. All right, so with that in mind, we're now going to go to the first method, which is when we don't do a calibration. We're just going to go straight out and identify the cable. So I'll turn the unit on. Here we go. Starts up. I want to do an ID, which is this button over here. It says to you, this is a short cable, less than 600 feet. And yes, it is. So we need to pick one, and off it goes. So we're going to go down over here. And Cody, you want to just shine that up there? Actually, I'm going to have to look at it too. But you can see we should start to see information come out. And that's showing a negative. So that means we're on the C phase. Underneath this cable, we are closer to the C phase. Now, as I move it, I'm going to move it slightly around the cable. We should start to see L1 and or L2. Can you get a better shot of that? You're not quite getting it right, Cody. No, you can't see it properly. There we go, that's better. So there we have L2. What's the current there, Cody?
5.24 amps.
All right. Now, so that's quite a big current. I'm going to move it slightly, ever so slightly around, and you'll see the current changes. What's the current there?
5.52.
Okay, so that's even higher. That means we're really on top of L2. Now, if I move it slightly again, it should start to drop off.
Yep, 4.83.
4.8. So if I go back over there, right underneath this puck at the moment is where L2 exists in this cable. If you wouldn't mind going back to the operation manual, we have a little screenshot to show you. If you can just zoom in on that. Right now, we've picked up the maximum of L2. Can you go to like 2 o'clock? If you look at 2 o'clock there on that screen, you can see the maximum of L2 appearing there. You see that? So at 2 o'clock there, you can see the L2 and being a maximum. You see the 3 plus signs there. And as we move around, what's your current now, Cody?
See, we're at 5.47.
Yeah, so if I go around even more, I'm going to start to lose that current on L2.
4.47?
Yeah. If I keep going, I should either pick up L1 or the return. So let's have a look at what we've got over here. There's L1 coming in. What's the current?
3.56.
So let's move a little bit more around, and it should go up.
4.17.
Right, so now we're reaching the peak, and that makes sense because the phases are about 120 degrees opposed to one another in the geometry of the cable. If I move it all the way around, then I should also now pick up the negative, the return. There we go. Let's see what you pick up there now, and you should hopefully get a big negative, and there we go. So on this particular cable, we've identified 3 bits of information. We've identified A phase, B phase, and the return. If you had to go in that same manhole or the same trench and look at any other cable, you would not have that information on any other cable. Only the cable in question. So not are you identifying the cable in question, but you're actually identifying the phasing under the cable. So one of our utilities, they will actually mark on the outside of the jacket A phase, B phase, and C phase. So when they cut, they already know what the phasing is underneath the cable. So they can make sure that whatever they join to it, the A goes to the A, the B to B, and the C to C, etc. So it's a very powerful tool of not only identification, but also of phase identification as well.
All right, so what we have here is a 3-phase cable setup in direct mode. A little bit more representative of what you might find out in the field. So what we have here is A phase. We are connected through L1, and then our black return is turned to C phase. L2 is on our B phase, and with the black lead return going to C phase. On the far end of our cables, we have all 3 plugged into a 3-way parking bushing here. So all 3 of them are connected. So none of these, all the shields are grounded, but all 3 on the far end are all connected into one bushing there. So this will be our setup, and we will move up to the upstairs where the cables are coiled up, and we will read from there. We have our EasyID running and beeping on its 3-phase mode. So now we can take our EasyID. We are set to just identify mode, not doing the calibration. So we'll just come up here. If you want to follow with the camera, Cody. So it's telling us this is L1. We're getting about 3 amps. So this is L1. So we're now L1 here. Now we come over to our other cable. Now it's identifying again. So now it's telling us that we have L2 positive. So we have L1 positive for sure on our cable to our right, L2 positive on our cable over here. So now if we come to our third cable, we'll put our puck on. Now we should be seeing a negative signal, and it should be identifying negative. So if we hit our ID button, it says L1, hit ID again. L2, I might have to hold it, L1, L2. So now it's seeing both of these charges, unique signals coming down the line, and it's now showing that this is now the 3rd phase. So we have our L1 hooked up to L1 and our C phase, and then L2 is hooked up to our B phase and C phase, so then C is going to be our return for all of our signals. So now we're going to ID, We're gonna do new. We're gonna do short. And so now we're gonna verify short. So we're gonna come over to our A phase. We're gonna keep our coil over our shielded section because our cable is still shielded here. We're gonna have it point away from our transmitter. So our arrow is pointed away. So our arrow is pointed away. So it should come up with L1. Yep, L1, we okay, confirm. It's gonna read again. It should give us an L1 with a check mark. Now we're gonna move over to our B phase calibration. So it says L2 confirm, we are on L2. It's going to reread again. Should give us an L2 with a check mark, or L2 with a smiley face. So it is happy. So our calibration phase is done. If we want to go verify on our third phase that we are getting our return is good, we'll move over to our C phase. And we should see a negative. There we go, we see our negative. So if we hit ID, we should see L1, and hit ID again, we see L2. So we have now confirmed that our return is in fact good, and we're getting all of our unique signals back returned to us. And that is the calibration of the direct method. We'll move upstairs and do the identification of the direct method next. Important note, before we move upstairs, when you verify or ID a cable, it needs to be performed in what we call a like for like. So if you are IDing around a shielded section in the middle of a cable, you also need to verify on a shielded section. Same goes for identifying on a non-shielded section, like a termination. Calibration / verification should be done on a non-shielded section as well. So now that we're calibrated down below, now we are going to come up to our cables, of our unknown cables, and we're going to hook up and ID them with the calibration mode. So we're going to bring the camera over. All right, so it sees L1. Got the smiley face, so this has confirmed as L1. So now we can move on over to our next unknown cable. And as it's identifying, we should see, yep, L2 smiley face. So the smiley face indicates that we have at least 65% of the current that we measured down at our calibration phase. So right now we're getting 10.1 amps, so that's about what we got with our calibration phase, so perfect. So now we move over to our third phase. Once we hook on and it identifies. If I have the coil the right way, we should get a negative. And if we hit ID, L1, hit ID again, L2. So this verifies that both of our unique signals are now coming down on our return of our C phase. So now we have successfully identified all three phases. All right, so now we're going to show the indirect mode with the CT clamps. So this is when the cable is energized and you can't shut off the cable before you do maintenance on said cable. So now with the CT clamps, we are inducing into the shield into A phase and also inducing into the shield into B phase. Only 2 phases can be identified this way as compared to the direct mode where we can identify 3 phases at a time. Also note, this method can only be done between grounding points on the neutrals of the cables. So this is the calibrated mode. So we're going to go into ID, we're going to start a new session, and we're going to do short energized. So we're going to put our Rogowski coil over, and the way our setting is, we're set to face away from our transmitter. So now it's asking to confirm L1 because we're calibrating. We know we're on L1. Yes, we are. So now that we told it, it should give us a check mark. Yep. So we are check marked good. We're going to move down to our B phase. wants us to confirm. We're going to confirm it's L2. It's going to recheck, verify it again. Now it gives us a smiley face. It's happy, ready to go. All right. Now let's go over to our cables. All right, so now that we've verified our cables, and we're going to go and ID them in the indirect mode. So we're going to put our Rogowski coil on. So, yep, it's verified for us that L1 is happy, so this is our L1 that we've induced into the shield. Moving over to our next one that we're inducing into. We're inducing into B phase through the shield. If I put the coil on right, it should give us another smiley face with L2. Yep, so the coil's on the right direction. And then since we don't have a third coil or return, C phase will not be able to be checked, but we'll go over and just show what that would look like. So it's unsure. So that's what it should do because we don't have a third return path. So that is the EasyID indirect method.
Now we are going to demonstrate the indirect mode with the CT clamps. Notice the direction the arrows are pointing. That indicates the direction the pulse is going to be induced into the shield. With that being said, only one or two phases can be identified this way, as compared to the direct mode, where you can identify all three phases at a time. Note, indirect mode can only be done between grounding points on the neutrals of the cable.
Now we have the identification phase turned off. Our smiley face is turned down to 0%. We're going to do short energized. And now we just jump straight into the ID phase. So before we had our verify, now we just go straight into ID. So you should see in the top left that ID is there and does not say verify. All right, so now let's go into we'll start off at B phase, because we'll just say this is a random cable that we have decided to pick. We picked a random cable up here. We did not do the ID, so now it's saying, hey, this is L2. So now it is telling us that it's looking for that unique signal. This is L2. So now if we go over to our other cable over here, it should just go straight into reading L1. There we go. L1 positive. That's the one limitation to the inducing into the shield.
Is that you lose a lot of amplitude when you induce current through the air with the CT clamp versus inducing current through the conductor with the direct mode.
So now we're going to go over some of the settings in the EasyCable ID. So all of our settings are going to be under the menu tab. So under the menu tab, we have the home, system info, preferences. Normally, if the handheld unit is locked, this will be the last of your settings. But if it's unlocked like it currently is, you have the smiley face option, you have your sensor arrow, you have your cable length, your transmitter mode, and then contrast adjust and power save. Power save will also be there if your preferences are locked as well. So now let's go over the smiley face. So the smiley face, what it does, that is our calibrated or uncalibrated mode. So if I drop this smiley face all the way to 0%, so now it is off, we are in the non-calibrated mode. So if I turn on the unit, I hook up my test leads to my A phase, B phase, C phase, with my C being my return. I can just go straight out to the cable and start IDing. If I want to do a calibrated mode, I would turn the smiley face on. For our particular demo here, we use 65%. So what that does is when I go to calibrate, say, for example, I get 10 amps when I calibrate. When I go ID at my cable, it's looking for the unique signal, and it's also looking for at least 65% of that 10 amps. So I need at least 6.5 amps and that unique signal to give me the smiley face. So if I got the unique signal, but I only got 1 amp,
it's not going to give me a smiley face because I don't have 65% of the current that I calibrated with. That can be adjusted. So this is not just 65% is just what we had set here. If I wanted to take this higher and say I need 80%, so it's going to look for that unique signal and 80% of the current that I calibrated with. If you want to go lower, now say I only want to have 20% of the current. So on that 10 amps, if I only got 2 amps, that'll be just fine. It'll still give me the smiley face. So that is how to adjust the settings of the calibration mode, how to turn it off, and how to adjust the level. So now we're going to go back down to the next one. We're going to go to sensor arrow. So what sensor arrow does, it lets you determine whether you want to face the coil away from the transmitter or towards the transmitter. Some utilities like having all of their units set up to point towards the transmitter, and they won't accept it any other way. Some of them like to have it away from the transmitter and won't accept it any other way. This setting can be set here at the factory before we ship it out to you, or it can be adjusted when you receive it. If you wanted to change it the other way for some reason, that option is available to you. The supervisor can call in, get the code to unlock the handheld unit. They can go in and change that setting, relock it so it can't be changed by accident or something in the field the wrong way. So we're going to leave this one towards us. We're going to go back. So our last one here is going to be cable length. This just lets you, whether you want to select just having a long cable test or just a short cable test energized, or you can do both. So we leave the both turned on. Now something to note with the pointing the arrow away from the transmitter or towards the transmitter. Let's say, for example, you have it set up to point away from the transmitter. If I point my coil towards the transmitter and I'm on A phase, I will get a negative impulse or a negative signal. I should get a positive signal if my coil is faced the right way. So the fact that I'm getting a negative signal means I have the coil pointed the wrong direction. I can also hit the ID button, that would be this bottom right one when I'm IDing a cable, and it'll show me just having the L1 signal. So when I flip my coil around, it'll then go L1 positive. Same goes for my return. I should have a negative signal on my return, but if my coil is faced the wrong way, it'll show me a positive signal. But I could still ID both signals with that bottom right button when I'm IDing. It'll show me positive L1, positive L2. And if I flip the coil the other way, I should get a negative L1 and a negative L2. So that's something to keep in mind with the transmitter, finding which way you have the coil placed, and that is the settings for the EZ ID.